All right, here we go. 1.1 exponential function from 2 data points, okay? We've been spending a lot of times like, doing everything with the calculator, right? We're going to talk about solving by hand, like learning, just reviewing some basic math skills, and hopefully you feel okay about it, all right? Let's see how it goes. It says here, Dylan releases new music on one of his social media platforms. One particular song of his had 500 listens on the day he released it and 1,725 listens 5 days after he released it. Write an exponential function model for the scenario and use it to estimate the number of listens he might expect the song to get 21 days after he released it. Okay, so the first thing you want to do is identify your ordered pairs. So what would be your ordered pairs here? There we go. So we have 0 and 500, and we had what? 5 and 1,725. Are we all in agreement with the ordered pairs? We see where they came from? Okay. The next thing we're going to do is, remember, we're working on y equals a times b to the x, right? So we need to be able to find our b. So step 2 is to find the b. Okay. To find your b is fairly easy. There's a formula to find the b, but if all else fails, you can plug in and solve for the b. Okay. But the formula for solving your b is b equals your y2 divided by your y1 to the 1 divided by x2 minus x1. That is how you calculate your b, given 2 points. It's a formula. Okay, so it's 1 divided by x2 minus x1. 1 divided by, my 1 got a little funky. I'll fix it. Let's see. All right. No, it's not. Can you find slope? Have you not found slope before? These are exact same letters we use to find slope. We subtract and divide when we find slope, do we not? Oh, I know. Remember? Okay. 1 divided by x2 minus x1. Okay? You have your x1, your y1, your x2, and your y2. So what are you doing? You're just plugging in. So if I'm looking for my b for this problem equals, what's my y2? 1,725. What's my y1? 500. Divided by 1 to the power of 1 divided by, what is my x2? 5. And what's my x1? 0. So now I just got to put this in a calculator, and you can put this in any calculator, right? It doesn't require a graphing calculator or anything fancy. I'm going to look, guys. I upgraded my calculator. Okay, so I'm putting in parentheses. I put in parentheses because I can't make a fraction on my calculator still, but yeah, you can. You press the alpha button and then the variable button. Alpha and the button next to it. Obviously, you didn't do your scavenger hunt from the beginning of the year. Okay, then I'm going to raise it. And now look, when I raise, guys, I get little numbers too. Okay, 1 divided by, and what's 5 minus 0? 5. 5. We heard you. All right, I'm gonna press enter. What does it tell me that my b value is? Okay, so I'm going to tell you right now, for AP, pre-AP math on College Board, they want you to start rounding. I looked it up. I was trying to figure out, because I don't know what your test looks like that you're taking next Monday. We're going into this blind, okay? But from what I looked at, they want you to round to the nearest 3 decimal places. So we're going to practice rounding to our thousands. 3 decimal places is your thousands. Okay. Oh, did I pass? Yeah, you did. All right, so we found our B. Check. Boom. Was it terrible? Okay, next we're going to find our A. Okay, if you have a 0, your A is just at x equals 0. So whatever value is at x equals 0, that's your A. So on this problem, it's easy because we have it. Otherwise, we would have to solve for it. So what is our A? 500. Because at x equals 0, what is y? 500. So what is our A? 500. It's our initial value. Yes, it is. When x is 0, yes. So your y-intercept. So define your A. It's at x equals 0. So if I go to 0, what's 500? Well, it's 500. Our x, when x equals 0, what does y equal? 500. Then we're going to do one when it's not there. Okay. Step 4 is to write your equation. So our equation is y equals, what's our A? 500 times B, what's our B? To the x. Okay. 4 simple steps, right? All right, now we can answer the question. It says on 21 days. So answering the question, it says 21 days. So that means x equals 21. So if x equals 21, what is y? So we have y equals 500 times 1 and 281 thousandths to the 21. I'll put this in the calculator. Let me pull up my handy dandy calculator. It says on 21 days after. So we have 500 times 1 and 281 thousandths to the 21. Okay. Now I want to show y'all something. If you notice here how my calculator automatically rounds for me. Remember, if you're not strong at rounding, you can go to mode, go to float, and switch it to 3, and the calculator will do the rounding for you. You just hit second mode to get out of it. You quit. Okay. So now when I hit enter, it's going to tell me about how many likes do I have now. Can I have a fraction of a like? No. So the 9 is going to round to 7 too. And 8. So I have about 90,000. What was it? 78 likes. Or listens, not likes. All right, how do we feel? Decent? Not terrible, right? Yeah. Cool. All right, we're going to do another one, but this time we're not going to be at 0. Does that make sense? Okay. I think, oh, this is not it. We're going to do another one at 0. My bad. I looked at it wrong. All right, here we go. Step 1 is to do what? Ordered pairs. So let's see. Magna has cats who has fleas. A veterinarian recommended treatment plan that includes combing out her cat's fur every day. Magna put on some real special glasses and kept track of the number of fleas she removed from her cats while combing them out. On day 0, the day she started the treatment, she removed a total of 87 fleas. On day 6, she removed a total of 14 fleas. If Magna keeps up the treatment and the number of fleas can be modeled by an exponential function, approximate the number of fleas she should expect to remove from the cats on day 14. She has more than one cat. It's plural. It's cats. We don't know how many she has. She could have 10 and they each had 8 fleas. All right. What are our ordered pairs? 0 and 87 and 6 and 14. Easy enough? So the first thing we're going to solve for is our B. And B equals y2 divided by y1 to the 1 divided by x2 minus x1. Do I know all these variables? Yes. Here's my x1, my y1, my x2, and my y2. So we're going to plug everything in. We have B equals 14 over 87, which means that they're decreasing, right? We can see it's a decrease, to the 1 divided by 6 minus 0. Okay, so approximately, what's her rate? What is her growth factor? Okay. Yeah, so we're good. I'm going to model it. 14 divided by 87 to the 1 divided by 6. Did we all get? So 0.738 is our growth factor. It's okay. You're only going to know 10% of it. Oh, don't do that. All right. So that's our B. Good? All right. Step 3 is to identify our A. And that's our value at x equals 0. So what is it? 87. A equals 87. Step 4 is to write our equation in the form of y equals A times B to the x. So y equals times to the x. Okay. Step 5 is this: to answer their question. If there's a question, is there an additional part that it wants us to find out? Day 14. So on day 14, how many fleas should Magna pick out? So x equals 14. So y equals 87 times 0.738 to the 14. And she should have approximately 1 flea left. It must be a 2-week treatment. 2-week flea treatment. Is it terrible? Gotta admit, guys, it's not bad, right? Doable? No. If you want to, but you don't put my leave. Oh, I'm glad you asked. No, you got to put the value. Here we go. All right, we're going to talk about our friend Naomi here. Naomi is a social scientist who is studying how a rumor travels through a community. Naomi tracked that 7 people had heard the information 2 days after it was introduced to the community. Then she tracked that 11 people had heard the rumor 5 days after the information was introduced to the community. Write an exponential function that Naomi could use to model the scenario and use it to predict the number of people who have heard the rumor 20 days after the rumor, okay? What I want you guys to do at your table is you're going to do steps 1 and 2. And then we're going to come back together, okay? And we're going to do 3 together because that's where it changes. Got it? You're going to do 1 and 2 at your table. And then we're all going to come back together and go from there. I will be walking let's check in on steps 1 and 2. See how we did, okay? So on step 1, what were your ordered pairs? 2 and 7 and 5 and 11. Good? Okay, remember time is our independent variable, right? Can we control time? Nope. All right, step 2 was to find our b. And remember, b equals y2 divided by y1 to the 1 divided by x2 minus x1. Did we have everything we needed? Yes, so the b for this problem is approximately, what is it? 11 divided by 7 to the 1, and that's 5 minus 2. In the calculator, you would put this as what? 3, right? 5 minus 2 is 3. All right, so what did you get? Perfect. Okay. So your B is approximately 1.163. All right. Notice here that we do not have an A at 0, right? So therefore, on step 3, we have to substitute in what we have to solve for A. So we have to actually solve for A. Okay? To solve for A, you're just using your x2, your x1, your y1, and your b value, such as y1 equals A times b to the x1. That's it. You're just plugging in your what the x and y's you have for x and y. Does that make sense? So we're going to substitute. What is y1? What did you use as y1? 7. What was our A? We don't know. What's our B? What's our B? 1 and 163 thousandths. And what is our x1? 2. Okay? So this is multiplication, right? What is the opposite of multiplication? Division. So I'm going to divide this side by 1 and 163 to the second. And that's going to cancel it out. Is my A now by itself? So this is the value of my A. I just got to put it in the calculator now. It's our x1, y1, right? All right, so in the calculator, we put in 7 divided by perfect. 7 divided by 1 and 163 thousandths squared, and we get 5. Okay. So can you have 1/7 of a human? No. So just, I mean, we're gonna leave that, but it's our rate. I don't know why I said that, guys. That's our A. Miss Jones is tripping. She needs to go to sleep. So that's our A value. Can I write my equation now? Yeah, because all I needed was A and P. We got it, son. So Y equals 5 and 175 thousandths times 1 and 163 thousandths to the X. All right, so step 5, is there a further part to this? Yes, they want to know on 20 days. So if when X equals 20, what do we get? So I'm going to go to my calculator. And I'm going to plug in 20. So I have 5 and 175 times 1 and 163 thousandths to the 20th. So after 20 days of this rumor roaming this town, how many people know now? About 106 people. So Y is approximately 106 people. So our growth factor is how quickly that rumor is spreading, right? Okay. What is the percent change? Anyone? There you go. Good job. Your percent change is 16%. Remember, this is saying how far am I from 100%? Remember part A, that's percent change. How far from 100%, which is 1, is this amount, right? It's 0.16, right? So 16% would be our percent change, okay? So every day, 16% more of the population are knowing whatever the rumor is, okay? All right, I want you to practice now. It's not, okay? This is not part of it. This is just a noun, richest 1% of people. It's just what they're called, the richest 1% people, richest people in the world, in America. Okay.
Do you want us to go by
Well, we do exponentials and there's years. What do we do with the first one? That's our 0, because otherwise the numbers will get too large. They would get too big and it won't be able to calculate. Okay. So we start, even though it's a year, this is what? This is our 0. And this is how many years from that. Okay. I'm going to stop talking and I want y'all to try to work it completely.
So that's 4 years. So that'll be
40 years?
4.
40 years?
4.
40 years?
40 years, but
okay.
like 10 is 4.
No, it's 40 years. 2019 is 40 years. Exactly, because this is 40 years from there, right? And you put decimals because you can't put percents in, right? All right. All right. All right, so at this point, you should have come up with, so you had 1979 and 23% we're gonna write as 0.23, 23 hundredths. And then we have 2019 and we're going to write it as 35 hundredths. All right, we talked about before, we don't use years because they usually get too large with exponentials. So we're gonna let this be 0. And this is 40 years later, so this is going to be 40. So then step 2 is you're going to find your B value. Remember, B equals Y2 divided by Y1 to the 1 divided by, and I'm going to put parentheses because as I walked around, I saw a lot of you not simplifying this first, okay? So we have B equals, and that's going to give us 35 hundredths divided by 23 hundredths. As you can see here, this value is greater than 1. So we know that it's an increase, which makes sense because we went from 23 to 35%. To the 1 divided by, and we have 40 minus 0. Okay, so we're going to go to our calculator. Open our calculator, and we're going to put in 35 hundredths. Notice that I don't have the handy dandy calculator feature like you where I can make it a fraction. So I have to protect my fraction with parentheses. Divided by 23 hundredths to the, and 40 minus 0 is 40. So to the 1/40th power. Hit enter. And we get that our B value is approximately 1 and 11 thousandths. Okay. Now we're going to find our A value. This time our A is given to us. This time our A is the value at x equals 0. So in this case, A equals 23 hundredths. So now we can write our equation. So our equation is y equals 23 hundredths times 1 and 11 thousandths to the x. Okay. Step 5 is only if there's an additional part they want you to solve. Step 5, it says how many were in 1995. So in order to find the x here that we're looking for, we're going to have to do a little subtraction. So we're going to have to do 1995 minus 1979, which equals 16. So our x value is going to be 16. So I have 23 hundredths times 1 and 11 thousandths to the 16th power. Open my calculator. This is the only thing about this new calculator. It will not stay on the screen. So we have 23, 1 and 11 thousandths, I'm sorry. Close parentheses to the 16th power. And I get, this is approximately 274 thousandths, which means that this is approximately 27.4% is what the percentage was in 1995. Okay. All right. Here is our last one that I want you to pause and do. All right. Welcome back. Let's see how you did. So it says, Ish is performing an experiment to investigate how quickly certain strand of bacteria reproduces in a controlled environment. She places 1,000 bacteria in a petri dish on day 1. On day 4 of the experiment, she observes 2,000 bacteria in the petri dish. She reasons that the bacteria population is doubling every 4 days. She predicts that the bacteria population continues to grow at this rate. The petri dish should contain 4,000 bacteria on day 8, and 3,000 is halfway between 2,000 and 4,000. So day 6, for day 6. So day 4 and day 8, she should expect about 30,000 bacteria to be present on day 6 because of that. So we're going to use an exponential function to construct an argument to confirm or refute Ish's reasoning. So step 1, again, is to start off with our ordered pair. So our ordered pair would be 0, and 1,000. Remember, we're going to always let time, majority of the time, is going to be our independent variable. And then day 4, we had 2,000. So now we're going to solve for our B. So B equals 2,000 divided by 1,000 to the 1 divided by 4 minus 0. Okay, so I'm going to go to my handy dandy calculadora. I'm going to put that in. So 2,000 divided by 1,000. And now, could you simplify as you're doing this? Of course. To the 1/4. So I press enter, and I get 1 in 189 thousandths. So my B is approximately 1 in 189,000. Okay, step 3 is to solve for my A. Well, I have my A because I have a value at 0. So my A equals 1,000. So then my equation is going to be Y equals 1,000.
The TIA meeting is in the.
Sorry for that. So Y equals A, 1,000 times B, 1 in 189 thousandths to the X. So here is my Y. Okay. It wants to know, was she correct about day 6? Okay. And obviously we need to also verify whether we're right about day 8. So we're going to find the values of day 6 and day 8. When I have more than one X value to find, I like to use the table. So we have X equals 6 and we have X equals 8. So this time I'm going to utilize the table. So I'm going to open. Put this over here. I'm going to go to Y equals. And I'm going to put in 1,000 times 1 and 189 to the X. Okay. So I'm going to hit second table. And I'm looking for what is the value at 6. So at 6, I have 2,825. I'm going to scroll down to 8. And 8, I have about 3,994. So we have 2,025. So X equals 6, Y equals 2,000. I forgot that quick, y'all. We go back. 2,825. Well, the 5 is going to round it up to a 6. So 2,826. 26 bacteria. And at 8, we had Y equals 3,994 bacteria. Okay. The other thing I want to just reiterate is that we have gone through the steps of doing this as a regression model. So keeping that in mind, you can always follow our steps for creating a table using stat edit. So if I wanted to solve this with the regression model, remember step 1, you're going to go to stat. And you're going to press 1 for edit. And then you're going to input your values. And then after your input, you're going to press stat again. Then after you press stat, you're then going to arrow over to calc. And at calc, we're going to press 0 for exponential regression. Okay. So it's still step 1. It's technically step 2 because you find your ordered pairs. Now you're going to go to stat, edit, and put them in. After you do that, you then are going to press calculate to get your values. Okay. If we want to be more precise before pressing calculate to get our values, we are going to practice changing, putting in our y2. So here we go. So I'm going to open my calculator and we're going to follow these steps that are up here. So I'm going to clear, just going to second plus 712. I'm going to go to stat edit. I'm going to input my values that we said, and our values were 0, 4, and I'm going to put in 1,000. Notice how I'm making sure my X's and Y's are staying together. 2,000. Then stat edit input, and now we're going to go back to stat. Then when I go back to stat, I'm going to go to calc, arrow right to calc. And I want to press 0, but I'm going to scroll so that you can see why I'm pressing 0. 0 is going to take me to exponential regression, expreg. So I'm going to press 0. And it's going to say, do you want to calculate? I'm like, oh yeah, I love to calculate. Okay. But we're going to go right here where it says store regression equation, to store our regression equation so that it can hold our values and calculate to the most accurate possible. I would press vars here, go over to y vars, and I want to create a function. And I say, yes, I want you to create me a function. And I'm going to arrow down and then press calculate. So it gives me my values, which OMG, look at that. We're pretty darn smart, guys. We did that. But when I go to y equals, it also puts the values in to a T, as many decimals as the calculator allows it. So when I go look at my table, second graph to look at my table, look at my values here. So it's actually 2 more bacteria, 2,828. And here we have 4,000. So 8 is 4,000. Okay. Notice how that rounding of the decimal really can alter, especially with exponentials, because of how quickly they grow. All right. So be mindful of that as you're working. You want to hold on to as many variables as possible, to many values as possible. Okay. All right. So yeah, there we go. That concludes.